Okay, hello guys, we're going to discuss something very important in geometry, generally in mathematics, and this is a topic I want to pick out from trigonometry. Trigonometry generally has to do with the study of triangles. When we are studying triangles, one of the most important triangles we deal with is the right angle triangle, because every triangle can be bisected and be partitioned into smaller right angle triangles. What makes the right angle triangle what it is just one thing, and that is this. The box you see here, and that box represents 90 degrees. So that's what makes a right angle triangle a right angle triangle. It's just because of the box. And once any triangle contains this box, it's called a right angle triangle. And since it is a unique triangle which we discuss and we deal with most times in mathematics, it is good for we to know the unique sides. And the sides here is called, the longest side there is called the hypotenuse, which is the same as the square of the sum of this opposite side and also this adjacent side. So we have a mathematician, Pythagoras, around 640, 620 BC, who proposed a theorem which we call the Pythagoras Theorem. And what is the job of the Pythagoras Theorem? Is simply telling you that the square of this hypotenuse, is going to be the same thing as the square of this plus the square of the opposite plus the square of the adjacent side. This is what we call the Pythagoras Theorem. Very popular, and it has been used for ages. So if my triangle is, for instance, ABC with respect to construction, it means that the side BC, the square of the magnitude of the side BC is going to be the same thing as the square of the opposite side, which is AC squared, plus the adjacent side, which is AB squared. So once we use this, we can conclude on what we call the Pythagoras Theorem. But notwithstanding, my Pythagoras Theorem is somehow limited, because to use the Pythagoras Theorem, you just have to be given two sides for you to find the third side. But what if we have information of this angle, which we call the acute angle? The acute angle here, theta. What if we have the information? What can we do with that? Then, and what can we, which side of the right angle triangle can we solve, having the information of this theta? The most important thing is to know what we call the trigonometric ratio. The trigonometric ratio, or basic trigonometric ratio, is what we call the basic trigonometric ratio. And that is what we call the sine theta, which I can shorten as sin theta. We also have the cos theta, and we also have the tan theta. These three ratios, as you can see, are named with respect to the sides, the unique sides of the right angle triangle. So we have the sine theta to give us the opposite divided by the hypotenuse side. Then we have the cos theta to give us the adjacent and the hypotenuse side. And we also have tan theta to give us the opposite over the adjacent. But I always advise students to see tan theta as the ratio of sine theta over cos theta. So these three ratios can be summarized as this. So you can have something like this as a reminder, which you can call SOHCAHTOA. This is just a reminder, something you can just think of anytime you want to resolve or want to solve problems on trigonometric ratio. So you can always think as SOHCAHTOA. It's an acronym that is used for basic trigonometric ratio. Now, what's my point? We want to also view these three basic trigonometric ratio and also see their reciprocal. What if we find the reciprocal of these ratios? I mean, like literally turning them upside down. That is what I mean. What will happen to sine theta when it is 1 over sine theta? That is what we call cosec theta. So we call this cosec theta. What will happen to this if it was upside down? Cos theta, if it was upside down, 1 over cos theta. this will be regarded as sec theta. This is actually secant. Sec actually represents secant, and this represents cosecant theta. So this, and this, and also for tan, if it was kept upside down, is going to be written as 1 over tan theta, and that is what we call cot theta, or the full meaning, which is cotangent theta. So this is 1, 2, 3 are called basic trigonometric ratios: sine, cos, and tan, while cosec theta, sec theta, and cot theta are actually referred to as the reciprocal of basic ratio. But please, I want to give you a warning. And what is a warning? Do not confuse tan inverse of x or theta, tan inverse of theta, to be 1 over tan theta. Please, many students do this mistake, and I need to do that warning, because this is not to be compared. Now, also, sine inverse of x is not the same thing as 1 over sine x. You must be very careful not to make this mistake. This sine inverse of x is what we call arc sine x, which is the inverse trigonometric ratio, while 1 over sine x is the reciprocal of basic ratio. It is good I show you this so that you don't make mistake or confuse this. This is a mistake that is generally done in mathematics, and I need to clear the air. Okay, another thing I want to show you is very, very vital, and that is a graph of these three functions. The graph of these three functions. So we have, I'm going to have this. Let's say we have one here. This is the y-axis. This is the x-axis. Y-axis. Let me call this the theta axis or x-axis. Leave it as x-axis. And this is the origin. And this. So I want to illustrate the sine graph. So if we have here pi in radians, and here we have 2 pi, and here we have 3 pi, and so on and so forth. Pi in radians. Please take note that pi radians is equal to 180 degrees, while 1 radian is 57.3 degrees, and pi remains 22/7, please approximately. I need to give you this information so that you don't confuse this to this. So sometimes I'm going to explain that in one of my videos, the difference between the domain of a trigonometric function and also the multiple of a trigonometric function. So if I was to draw a sine graph is going to take this form. I'm going to go this way. I'm sorry for my graph. You have to pardon me. This is hands-free. So the trigonometric graph for sine x or sine theta will always go this way. Will always take this direction, and that is why it is called the sinusoidal graph. Let me give this as a call. Okay, I've gotten this. So this is 3 pi. So this graph is what we call the sine graph, and it's also called the sinusoidal graph. The sinusoidal graph, and we also have the cos graph. This is 1, and this is pi. This is 2 pi. We have 3 pi, and so on and so forth. And this is the x-axis. This is the y-axis. You can literally know that this cos graph starts from here. It's going to go this way, it's going to go this way, and this, and this, and it's going to maintain that shape. It's not going to start from the origin, because cos of 0 gives us exactly 1. And that is pi over 2. Here we have pi over 2. So take note, here we have pi over 2, which is actually 90 degrees. Pi over 2 radians is 90 degrees. So this is what we call the y equals to cos x graph. What about the tan graph? I want to give you the tan graph. It's actually very, very funny and interesting graph. We have the asymptotes. We have what we call the asymptotes. That is the no-go area for, I think I have here pi over 2. Pi, here we have 3 pi over 2, and here we have 5 pi over 2, that interval. So you're going to have something like this. you're going to have something of this nature. So you have something of this nature. And you're not supposed to touch this. So you have this. Sorry, pardon my graph. Very interesting graph. So you're going to have this, avoiding the asymptotes, this value, this is pi over 2, and this place remains pi. This is going to be pi, and so on and so forth. So this is what we refer to as, this is 1, this is y-axis, this is the x-axis, this is the origin, and this is actually the y equals to tan x graph. So this graph, and this graph actually represent this trigonometric ratio. Sorry, I have to return my right angle triangle with theta, and this is the hypotenuse. So this is a right angle triangle, and what you see here can be used to solve a lot of problems. But one of the things we need to know is that when we take the right angle triangle, we can do a lot of work with it. The first thing is that when we have actually the Pythagoras Theorem, I can decide to get the ratio of this. I can decide to divide all what you have there with hypotenuse. I mean this equation, divide all this with hypotenuse. I'm going to have hypotenuse over hypotenuse squared. And we're going to have opposite over hypotenuse squared. And we're going to have adjacent over hypotenuse squared. But recall that this is 1 by ratio, and opposite by hypotenuse is sine. So I'm going to have sine theta squared, and adjacent over hypotenuse is going to give us cos theta all squared, and that is going to give us cos square theta plus sine square theta equals to 1. So this ratio is a very popular ratio, and it can be defined this way. You can generate many more ratios from this. How can you do that? If I divide it by cos square theta, cos square theta divided by cos square theta, and sine square theta divided by cos square theta, and 1 all over cos square theta, you can see that this is going to give us 1. So I'm looking for a space on the board. So this is going to give us 1, and this is going to give us tan square theta, and this is going to give us 1 over cos. You recall 1 over cos is the same thing as sec square theta. So these are trigonometric ratios, and I'm going to apply this in the next video in solving a particular question. Thank you very much.